We shall see the application of improper integral in one of the most useful tools in mathematics called Laplace transform. Here is the definition. The Laplace transform of a function f, denoted by LF, is a function of s, defined as improper integral from 0 to infinity, exponential negative st times ft dt. Now, if this improper integral exists, it will give us an expression in terms of s, which means s will be the variable of the new function. Let's describe it in diagram. Let's say lowercase ft is here. Laplace transform will bring ft to a new function. Let's call it uppercase f s. Now we can view Laplace transform as a function that takes input lowercase ft and gives an output uppercase fs. The Laplace transform is named after 18th century French mathematician named Pierre-Simon Laplace. Here is his photograph. We shall now see how to derive the Laplace transform of some elementary functions. We start with a constant function ft equals 1. The Laplace of 1 by definition will be the improper integral from 0 to infinity of exponential negative st times 1 dt. Now it means we are taking limit of the integral from 0 to m exponential negative st dt as m increasing without bound. Now take note that the integral is with respect to t. Hence, we regard s as a constant in the integration. We do the integration exponential negative st, that will give us 1 over negative s exponential negative st. The integral boundary are from 0 to m. And then we will take the limit of m increasing without bound. Now, this will give us since the limit is taken with regard to m, we can rearrange the terms, the expressions, and obtain this. Now we learned earlier on that this limit will be 0 if s is positive. Thus, the Laplace of 1 is 1 over s. This is our new function in terms of s, and the domain of this function is for s positive. Next, we discuss the Laplace transform of sine t. By definition, the Laplace of sine t is the improper integral from 0 to infinity exponential negative st times sine t dt. Now we write this in terms of the limit. Let's consider the integral of exponential negative st sine t. Call that integral I. Using integration by parts, we will obtain these expressions for the integral I. Let us simplify the expressions on the right hand side. Now for this integral, we shall use integration by parts one more time, and we will obtain this. Now, if you notice the expression inside the square brackets, we have the similar integral as what we start with, integral of exponential negative st sine t dt. So I shall rewrite this in terms of I as follows. Simplify algebraically, we will find the integral of exponential negative st sine t dt as follows, minus exponential negative st over s squared plus 1, multiply with cosine t plus s sine t. Hence, we shall continue to find the improper integral, that is to find the Laplace of sine t, which will be, let us rewrite the definition that we started with. Now, this limit is the limit of negative exponential negative st over s squared plus 1 times cosine t plus s sine t from 0 to m. Now we continue and we obtain this. We learned earlier on that this limit gives us 0 provided s is non-negative. Hence, the Laplace of sine t is 1 over s squared plus 1 for non-negative s. Next, you can continue. Try to find the Laplace transforms of these functions. And you will find the new functions uppercase fs as follows on the right hand column. Now the domain of the new function uppercase fs are given as follows.